All right, there's this other sort which is a non-monic. So that is when you have that a on your x squared. We want to be able to deal with that. So there's a couple of ways. Once again, you can use the cross method. We can use this other method. I think it's called pairing. I call it ACB to remind myself what I'm actually doing. So if we're doing the cross method, you need to look for two things that multiply together to give you 2x squared. So 2 times 1 is the only way to get the number. X times x is the only way to get x squared. And then we put our little cross. Then once again, we're trying to find 5, but this time it's negative 5. So we've got negative 5 and 1, 5 and negative 1. So we're putting in all the ways you can get negative 5 using the factors. But the thing is, because we've got this 2 here, we also have to flip it and do it the other way. So we have to do 1, negative 5, negative 1, 5. Because we need to consider all the ways we can multiply this 2 by things. And then we just multiply down the branches. So we do 2x times 1, which is 2x. X times negative 5, then add them together. So that one is negative 3x. Isn't the answer that we want. So then we do it again. So 2x times negative 1, negative 2x. X times 5, 5x. Add them together. That one works. But I just want to show you that we can do them all. So 2x times negative 5, negative 10x. We've got an x, so that would be negative 9x. And then we've got 10x and negative x. So positive 9x. So we can see that we don't want these ones because they don't get us the right answer, but we get these two instead. So one of our brackets is the top line. So 2x plus 5. And the other bracket is the bottom line, x minus 1. And that's how we factorize using the cross method. This other method most people don't show or use, but I prefer it to tell the truth because we don't have to think about the factors for the first thing, for the a. Once we do the first step, we just have to think about factors, which is like what we did with the first one, inspection method. So we call it A, C, B, or I call it ACB because they're the steps we do. A times C is what this is representing. So we can label them so we remember what they are. These letters, A, B, and C, only represent the numbers. So A doesn't represent 2x squared, it represents 2. B isn't 3x, it's 3, okay? And C is negative 5. The sign does belong to it. So for this one, we're doing 2 times negative 5, which is negative 10, and then we just state B. So now, just like with the inspection method, we're trying to find our factors of negative 10 that will add to 3. So 10, we've got 1 and 10, 2 and 5. Because it's negative, we're looking for a difference. The one with a difference of 3 is this one, and we need it to be negative 2, positive 5. Okay, this is the bit that messes some people's heads up. What we do now is we rewrite this quadratic, but instead of plus 3x, we're going to write minus 2x plus 5x. Because they equal the same thing, we're just splitting that 3 up and writing it in a different way. Negative 2x plus 5x still equals positive 3x. Now this is our grouping. We did grouping in another lesson. So we take out a common factor. For these first two terms, 2x is our common factor. And that leaves us with x minus 1. Then we take a common factor out of the second one, plus 5. Please make sure that this number has a sign. It should either be a plus or a minus. Leaves us with x minus 1. Okay, here the brackets must match. If the brackets don't match, you've done something wrong. Okay, so here I've got x minus 1 in both my brackets, so I'm on the right track. And then I've got one term here and one term here they have a common factor of x minus 1. So I'm going to take that out as a common factor. That's just like saying I have 2xa plus 5a, and I'm going to take a out as a common factor. Everything else goes in another bracket. So that's just what I'm going to do. I'm going to put everything else in my other bracket. And there we go, factorized. Now ACB looks a bit clunkier, but it is actually so much quicker. And when you have something like this one, 12x squared plus 11x minus 5, it is so much faster. If you were going to do the cross method with this one, you would have to consider all of the options for the factors of 12 in your crosses. You have to do 12x and x, and you have to do 6x and 2x, and you have to do 3x and 4x, and consider all of those. Then consider all your factors of -5, which is clunky, annoying, and we don't want to do that. So for this one, ACB is a lot quicker. So ACB. I know it's not alphabetical, it bugs me as well. All right, so A times C is -60, and B is 11, factors of 60. Okay, so we start with 1, and then you think 2. Does 2 times anything to get me there? Yes. 3 times anything? Yes. 4. Yes. 5. 6. And then, you just keep going until you get to really close numbers, which we've already got here, 6 and 10, because 7 doesn't do anything, 8 doesn't do anything, 9 doesn't do anything. Then we get back to 10, and we don't have to think about it because, well, we've obviously looked at all those numbers. Okay, it's negative, so we know we're looking for a difference of 11, which is this one. And it's positive 11, so our 4 is negative. All right, next step, we rewrite our polynomial, but it doesn't matter which way you write your two new factors, because it'll work either way. All right, and we write them down. And then we split and find a common factor. So between 12 and 15, there's 3, and there's an x in both terms, which leaves me with 4x plus 5. Okay. Now sometimes your common factor will actually be 1, but in this case it's -1, because remember we want our brackets to match. So obviously I need a 4x plus 5. So what times 4x plus 5 will get me -4x minus 5? -1. Don't have to write the 1 there, can just write a negative. And then we take that bracket out as our common factor. And there we go. Factorise. Didn't have to think about 3 lots of crosses. Didn't have to think about a bunch of factors and multiplication. Done. Just the factors of 60. Sub back in. Group it. There is your questions for this one. Question 10 is beautiful once you get it. It's all about letting something equal your bracket. It is very nice.